So in the last session, just we are discussing about vararg methods, overriding with respect to static methods we completed. So what are various overriding rules we covered. Now in this session, let me talk about overriding with respect to vararg methods. Okay, keep subheading. Overriding with respect to vararg methods. Overriding with respect to vararg methods. Okay, so not required to keep explanation what is vararg method. Okay, do you know? I hope you people may aware a new concept which came in which version? 1.5 version. A new concept which came in 1.5 version is the vararg method. Sir, I am taking m1 of int x. Just observe m1 of int x. We can call this method by passing exactly one int value. Correct or not? We can call this method by passing exactly one int value, right? But so if I can take like m1 of int dot x, we can call this method by passing any number of int values including 0 number. Do you know? This concept is nothing but vararg method, a new concept which came in the 1.5 version, right? Okay, overriding with respect to vararg methods. What is the rule here is, just observe a bit carefully. Here I am taking, so class, here observe, class P, I am taking parent class. Parent class contain public void m1 method is there, int dot x, public void m1 int dot x, system dot out dot println. Okay, this one is parent method. Okay, SOP of parent method, right? Now class C extends P, class C extends P. Okay, now I am taking a normal method, public void m1 of int x, normal method m1 of int x, system dot out dot println of child, like I am taking SOP of child, like this I am taking, right? So parent and the child. Now here just observe class test. Sir, I am taking class test. Okay, public static void main method string array args, class test, public static void main string array args. Now the target is, sir, here just observe parent class method is the vararg method, but of course child class method is the normal method, right? But parent and child. Now parent P is equal to new parent. Parent P is equal to new parent P dot m1 of 10. Sir, parent P is equal to new parent P dot m1 of 10. Next, child C is equal to new child C dot m1 of 10. Child C is equal to new child C dot m1 of 10. Parent P1 is equal to new child. Parent P1 is equal to new child P1 dot m1 of 10. Are you getting? P1 dot m1 of 10, like this we have. Now total, have you observed here? So P dot m1 of 10. In the first case, which method can legend? First case, which method can legend? Parent parent reference, parent object. Obviously parent method will get the chance. Parent. Next, second case, which method will get the chance? Child reference, child object. Obviously child method will get the chance. Okay, can you please tell in the last one which method can get the chance? Parent or child? Parent or child? Child. Parent. Is it child or parent? Very important. Parent or child? Because in overriding, method resolution always takes care by JVM based on runtime object. That's why what the answer we are going to get? Parent or child? Okay, make sure the answer is Are you getting? Any explanation is required? Why you are thinking, man, any explanation is required? Make sure some explanation must be required. Okay? The answer is parent but not the child. Okay, the answer is the parent but not child. Okay, this most of the people are going to feel, sir, it is nothing but parent, child, but not parent like. No, it is not child, it is the parent is the answer. Sir, why? What is the reason for that? Sir, in overriding, method resolution is always takes care by JVM based on runtime object. Correct or not? Based on runtime object, method resolution is always takes care by JVM, right? Sir, here runtime object is the child object. That's why child method should execute. But who told to you it is the overriding concept? Regarding who told you it is the overriding? In overriding, method names must be same. Argument types must be same. Sir, here what is the argument? Int dot x. But here what is the argument? Normal int. Both are same argument or different arguments? Different argument. If two methods having the same name but different argument types, what is this concept? Overloading but not overriding. Are you getting? So most of the people are going to fail. It is called overriding. No, it is overloading. It is overloading but not overloading but not overriding. Are you getting the point? Observe very carefully. Sir, a vararg method can be override with another vararg method only. If you are trying to override with a normal method, it will become overloading but not overriding. So in overloading, method resolution is always based on reference type by the compiler. In overloading, method resolution is always takes care by compiler based on reference type. Correct or not? Okay. Now observe this one. Sir, here which reference we are using? Parent reference, parent method. Which reference we are using? Child reference, child method. Which reference we are using? Parent reference, parent method. Clear for all of you? Take a bit special care. We can't override vararg method with a normal method. If we are trying to override vararg method with a normal method, then we will get it will become overloading but not overriding. Is it clear? A vararg method we should override with another vararg method only. Sir, here suppose I am overriding. It is also vararg method. It is also vararg method. Now it will become overriding. In this case, what the answer we are going to get? Child, right? Are you able to understand? I will execute and I will confirm. Just have a look once. Here just observe. Here I am taking 1 minute. Okay, here just observe 1 minute. Okay, here just have a look once. The same example, let me open here. So class test, let me save this code as a test.java. Okay, here see this one. If you observe class P, public void m1 of int dot p is nothing but parent method. Class C extends P, public void m1 of int I, normal method, child method, right? Are you getting? Now class test, public static void main, parent P is equal to new parent P dot m1 of 10, child C is equal to new child C dot m1 of 10, parent P1 is equal to new child P1 dot m1 of 10. Any explanation is required? Okay. Now let me execute this code. Here have you observed? Are you? 1 minute. Let me execute this code. Here Java C test.java. Java C test.java valid. Next Java test. Anna, can you tell what is the answer? First time parent, second time child, third time what? Parent. Have you observed? What is the answer? Parent, child, parent, like we are going to get the output. Sir, suppose if a child class method is also vararg method. Sir, child method is also vararg. Can you tell what is the answer now? Parent, child. Correct or not? Because now it will become overriding, right? Yes, the code compiles fine. What the answer by default we are going to get? Parent, child. Are you able to understand that? Okay, this is. So a vararg method we can override with another varargs method only. By mistake, if we are not overriding, if we are trying to override with a normal method, it will become overloading but not overriding. Clear for all of you? Okay, this at this point we can override varargs method. We can override varargs method with another varargs method only. We can override varargs method with another varargs method only. We can override varargs method with another varargs method only. If we are trying to override with a normal method, then it will become overloading. But not overriding. It will become overloading but not overriding. That's all. Are you able to understand, right? Okay, take this example clearly. Take this program and even add the comment also.
So what happened if that varargs takes single argument?
Can you repeat? If it is a normal method, then it is the overriding concept, right? Both are normal methods. Overriding.
When the varargs method takes single argument, means varargs method can take zero argument, single argument.
Here how many arguments we are passing? One. Then at that time which thing is going to be overloading or overriding? Even you are passing one argument only. Here how many arguments I passed in this example? One argument only. Overloading property is going to be dominated. So reference type, the corresponding method will get the chance. Getting the point, right? Correct. In this case, is it overloading or overriding? Overloading. So overloading method resolution is always takes care by compiler based on reference type. Here which reference I am using? In the parent, how many methods are there? That's why this is the only person who got the chance. If here one more method you can take, then what will happen is nothing but that method will get the chance instead of this. Take clearly. Make sure. So add the comment also. It is overloading but not overriding. Overloading but not overriding. Public void m1 of int dot x SOP of parent classic extends up public void m1 of int x SOP of child. So better to take clearly this thing also. Parent child parent child parent. Parent child parent like. Completed, I hope. Parent child parent like. That's all. Any explanation is required? Okay. So next at the point. In the above program, if we replace a child method, in the above program, if we replace a child method with a varargs method, if I replace a child method with vararg method, replace a child method with vararg method, then it will become then it will become then it will become overriding, because child method we are replacing with vararg method, then it will become overriding, overriding. In this case the output is can you spell out what is the output we are going to get? Parent child. In this case the output is parent, okay, child, next child, okay, that's all. Are you getting the point, right? This is what you people should aware, overriding with respect to vararg methods, right? Now keep subheading. Next the part, overriding with respect to variables, variables. Okay, this example is also a bit important example. Here see this one. Sir, I am taking class, take a bit special care, class P. Parent class contain int x is equal to 10. Class P, parent class contain int x is equal to 10. Class C extends P. Int x is equal to, sir, let me take int x is equal to some strong value 888. Int x is equal to 999. Are you getting that, sir? Sir, parent class contain 888, child class contain 999. Are you getting 888, 999? Same x only. Okay. Now observe this one. Sir, here I am taking class test, public static void main method, string array args. Class test, public static void main, string array args. Now the target is parent P is equal to new parent system.out.println p.x. Parent P is equal to new parent p.x. Next, child C is equal to new child system.out.println c.x. Child C is equal to new child c.x. Next, parent P1 is equal to new child system.out.println p1.x. Okay, like this. p1.x. Now SOP of p.x, c.x, p1.x, like. Here can you tell what is the answer we are going to get? First case, p.x. What is the answer? Parent reference, parent object. That's why what is the answer? 888. Parent value we will get. Child reference, child object. Then what is the answer? 999 we will get. Sir, parent reference but child object. Parent reference but child object. In overriding, method resolution is always based on what? Runtime object. Instance variables, right? Both are instance variable, not static variable. Can you tell what the output we will get? 888 or 999? Because runtime object is what object? Child object. Runtime object is what? Child object. That's why is nothing but the answer is 888 or 9. That's why the answer is 888 is the answer. Okay. Now my question is, who told to you it is overriding? Are you getting first point? Overriding concept applicable only for methods but not for variables. You are getting? Overriding concept applicable only for methods but not for variable. In overriding, method, I mean if it is the method resolution is always based on runtime object, but it's not overriding, because overriding concept not applicable for variables, right? Variable resolution always takes care by compiler based on reference type. Regarding variable resolution always takes care by compiler based on reference type. So whether the variable is instance variable, static variable, there is no change in the value is always the same. Okay, now sir, here observe, parent variable is instance variable, child variable is also, or otherwise instead of instance, non-static. Sir, parent variable is a non-static. Have you observed? Child variable is also non-static. Sir, both are non-static. Next, parent variable is a static and child variable is a non-static. Are you getting my point right? Static, non-static. Parent variable is non-static. Sir, parent variable is non-static, but child variable is static. Observe this one. Next, parent variable is, what is the last combination? Static. Child variable is static. Sir, observe, static. Whether the variable is static or non-static, there is no change in the rule. Variable resolution is always takes care by compiler. Variable resolution always takes care by compiler based on reference type. So that's why, sir, here which reference we are using? Parent reference 888. Sir, which reference we are using? 999. Child reference. Sir, which reference we are using? Parent reference. That's why 888 is the answer. That's all. Whether the variables are static, non-static, or non-static, static, or static, so there is no change in the rule. The rule is always same. That's why in all these cases, what is the output by default we are going to get here is 888, 999, 888. Correct or not? 888, 999, 888. Even in this case also, 888, 999, 888. Even in this case also, 888, 999, 888, and even 888, 999, 888, like this is the output by default we are going to get, right? Are you able to understand, right? Okay, this is the output by default we are going to get. I hope not required to keep any explanation about this terminology, right? Okay, at this point. So I will execute anyway. So first add the theory and then I will execute. Variable resolution always takes care by variable resolution always takes care by compiler, based on reference type. Variable resolution always takes care by compiler based on reference type. Irrespective of whether the variable is static or non-static. Irrespective of whether the variable is static or non-static. Next, within bracket, just spell out. Within bracket. Overriding concept applicable. Now, overriding concept applicable only for methods. Overriding concept applicable only for methods, but not for variables. Only for methods, but not for variables. That's all. And variable resolution always takes care by compiler based on reference type. Do you know? So now let me execute this code now. Same example here, just observe this one. Same example here, see. Sir, class P, index is equal to 888, class E extends P, index is equal to 999. Class test, parent P is equal to new parent P dot X, child C is equal to new child C dot X, Parent P1 is equal to new parent, new child P1 dot x. Now both are instance variables, instance variable, instance variable. Now the output we are going to get 888, 999, 888. Correct or not? 888, 999, 888. Now let me take the variable as a static. Sir, parent variable is a static, but child variable is non-static. No problem at all. Yes, same answer we are going to get 888, 999, 888. Sir, parent variable is a non-static, but child variable is a static. Child is a static. Same output by default we will get. There is no doubt at all. 888, 999, 888. Sir, parent variable is a static. Child variable is also static. No problem. Same output by default we will get. Are you getting the output right? 888, 999, 888. Are you able to understand? Irrespective of whether the variable is so static or non-static, there is no change in the rule. Variable resolution always takes care by compiler based on reference type. Clear for all of you, right? Okay. So take this example. This one followed by the table also. Completed, right? So better to take the table also. So overriding concept applicable only for methods but not for variables. Okay, make sure you people should aware. Okay, that's all. So these are various loopholes what you people should aware related to overriding, right? Okay, now very common question for the interview room, very common, very important. What is the difference between overloading and overriding? Can you please tell all differences between overloading and overriding? Maybe a chance to differentiate. Now that's all with respect to overriding completed. Now generalized points let me talk. Okay, this is which covers both overloading and overriding. Okay, keep subheading. Differences between overloading and overriding. Differences between overloading and overriding. Overloading and overriding. Overloading and overriding. Okay, differences between overloading and overriding. Here just observe, sir, with respect to which property, okay, which property we are going to compare. So first column property, second one overloading, third one overriding. overloading, third one overriding. Are you getting? So this is what we have to talk. Sir, with respect to which property? Overloading, overriding. Now my property, listen. So point by point, first one, here see. Method names. Sir, I am taking method names. Sir, can you tell method names must be same or different? Why? Names must be same whether it is overloading or overriding. In both cases must be same. Okay, listen. Later you can take first observe, must be same. Second one, argument types. Have you observed argument types? Okay, must be same or different? Overloading must be, okay, here must be different, must be different. Within bracket at least order, correct or not? Within bracket at least order, into float, float int, like you have to change the order at least. But in overriding, what is the rule, Anna? Must be same including, must be same including order, must be same including order. Method names, argument types. Third one, method signatures. Sir, these two things is nothing but method signature. Method signatures, method signatures. Sir, can you tell in overloading method signatures are same or different? Must be different because of different argument types. So method names and argument types is nothing but method signature. Because of different argument type, method signatures must be different. Method signatures must be different. But what about overriding? Method signatures must be same. Must be same. Next, here see. Fourth point here is, observe fourth one, legend. Return types. Have you observed return types? Return types. Sir, can you tell return types? Return types must be. Return types must be. Is there any rule in overloading? We never required to worry about return type. Maybe same, maybe different, no problem at all. In overloading, we have to check only method names must be same, argument types must be different. That's why return types, no rule or no restrictions. No restrictions. But what about overriding? What about overriding? Must be same until 1.4 version. But from 1.4 version onwards, must be same. Must be same until 1.4 version. But from 1.5 version onwards, 1.5 version onwards, which thing is allowed? Covariant return types. Return types allowed. Regarding covariant return types are allowed. Next one, fifth one, here observe. Fifth one, return types, okay, well. Next, private methods, static methods, private static, final methods. Private methods, static methods, final method. Private methods can be overloaded. Private methods can be overloaded. Static methods can be overloaded. Final methods can be overloaded. But final method, private method, static method cannot be override. You can't override these methods. So what the answer is? Can be overloaded. Can be overloaded, no restriction. Cannot be overridden. Cannot be overridden, like, okay. Next one, here see. Sir, public static and so on, right? Next, access modifiers. Access modifiers. Sir, is there any rule related to access modifier? First method private, second method public. No problem in overloading. So first method protected, second method public, no problem at all. But in overriding, clear rule is there. While overriding, the scope of access modifier we can't reduce. But if you want, we can increase the scope. That's why, no restrictions. No restrictions in overloading. But in overriding there is a rule. The scope of access modifier, cannot be reduced, but we can increase. Cannot be reduced, but we can increase. Are you getting that? Okay, this is. So private static final methods, access modifiers, right? Now the next terminology. Okay, here see. Have you remembered throws keyword? Like there is one more rule is there. Throws class. Have you remembered? Is there any throws restriction in overloading? No such type of restrictions. No restrictions. But there is one big rule is there. If a child class method throws any checked exception, compulsory parent class method should throw the same checked exception or its parent, but no restrictions for unchecked exceptions, right? If child class method throws any checked exception, compulsory parent class method should throw the same checked exception, or its parent, but no restrictions for unchecked exceptions. Okay, this one I will dictate anyway, not required to worry. And then last, 8th point, method resolution. Sir, method resolution, do you know who is going to take care in overloading? Always takes care by compiler based on reference time. Always takes care by compiler based on reference type. Sir, always takes care by JVM based on runtime object. Sir, last point. It is also known as, have you remembered? Overloading also known as overloading is also known as compile time polymorphism or static polymorphism or early binding. Correct or not? Method binding is going to be happen at compile time only, early binding. It is also known as overriding, also known as runtime polymorphism or dynamic polymorphism or late binding. That's all. Are you getting? If any person can ask what is the difference between overloading and overriding, then you have to tell these 9 differences, so that so we can give left and right to that interview person. Are you getting? If interview person is asking what is the difference between overloading and overriding, all possible differences with respect to syntax, all is nothing but these are the things. Okay, take the table first. I will dictate the points one by one. I will take the table, right? Property. Take the table first, and then I will dictate anyway. Property, overloading, overriding. Okay, like first one, method names must be same. Better to wait until dictating the point. I may add some extra theory also. Method names must be same. Okay. Second one, argument types must be different. Within bracket at least order. Argument types must be different within bracket at least order. Next, here must be same including order. Must be same including order. Argument types must be different, at least order. Must be same including order. Including order. Next, method signatures. Method signatures must be different because of different argument types. Must be different. Other side must be same. Must be different. Other side must be same. Must be different. Must be same. Must be same. You are getting? Must be different. Must be same. Next, return types. Return types. No restrictions. Return types, no restrictions. No restrictions. In overloading, we never going to worry about return types. But here add must be same until 1.4 version. Must be same until 1.4 version. But from 1.5 version onwards, covariant return types also allowed. But from 1.5 version onwards, covariant return types also allowed. Covariant return types also allowed. Covariant return types also allowed. That's all. Are you getting? Next one. Private static final methods. Sir, private static final methods. Private methods. Private static and final methods. Can be overloaded. So happily we can apply overloading concept for private method, static method and a final method. Can be overloaded. Other side cannot be overridden. Other side cannot be overridden. Okay, like next, access modifiers. So in overloading, access modifiers, what is the rule? No restriction. One method can be private, the other method can be public, no problem at all. Access modifier. Next, here add in overriding. Thus we can't reduce scope of access modifier. We can't reduce a scope of access modifier. We can't reduce a scope of access modifier. We can't reduce a scope of access modifier. But we can increase the scope. We can't reduce scope of access modifier, but we can increase the scope. We can increase the scope. Okay. Next, throws a class or throws keyword, any word you can use. Throws class, throws a statement like throws. So in overloading, no restrictions. Throws a class. Overloading, no restrictions. Next, other side, no restrictions. Other side, if a child class method throws, any checked exception, if child class method throws any checked exception, compulsory parent class method should throw. Compulsory parent class method should throw the same checked exception. Or its parent. or its parent, but no restrictions for, but no restrictions for, but no restrictions for unchecked exceptions, but no restrictions for unchecked exceptions, no restrictions for unchecked exceptions, unchecked exceptions. Okay, completed, right? Okay, this is next one. Method resolution. Next one, method resolution. Sir, method resolution always takes care by, oi, overloading. Method resolution always takes care by compiler based on reference type. Add method resolution always takes care by compiler, always takes care by compiler, always takes care by compiler based on reference type, always takes care by compiler based on reference type, always takes care by compiler based on reference type, type based on reference type. Next, other side, always takes care by JVM, always takes care by JVM based on runtime object, always takes care by JVM based on runtime object, based on runtime object, based on runtime object. That's all. Are you getting? Last point. It is also known as, it is also known as, it is also known as compile time polymorphism. It is also known as compile time polymorphism, compile time polymorphism or static polymorphism, compile time polymorphism or static polymorphism, compile time polymorphism or static polymorphism or early binding, compile time polymorphism or static polymorphism or early binding. Next, other side, runtime polymorphism, and it is also known as runtime polymorphism or dynamic polymorphism, runtime polymorphism or dynamic polymorphism or late binding, or late binding. That's all. So any explanation is required? Okay, make sure you people should have clarity, right? Okay, that's all. So these are the differences between overloading, overriding, right? But at the top, I want to give one simple conclusion by saying all these things. Sir, overloading, we have to check only method names and argument types. Method names must be same, argument types must be different. Are you getting? All the remaining things we are not required to check. What about return type? What about access modifier? What about throws keyword? These kind of things we are not required to check. In overloading, only two things we have to check. Method names must be same, argument types must be different. But in overriding, everything we have to check. It's a complex process. Are you getting? Method names we have to check, arguments we have to check, return types we have to check, access modifiers, so throws keyword, like complete prototype of the method we have to take care. Are you getting? At this point, take a note. So complete the table and then add. Note. In overloading, we have to check only method names. We have to check only method names. We have to check only method names. Within bracket, we have to check only method names. Within bracket must be. We have to check only method names. Within bracket must be same. Method names must be same. Bracket close. We have to check only method names and arguments and argument types. Argument types within bracket must be different. Argument types must be different. Must be different. Okay, next para. must be different. Next, we are not required to check, same continuation. We are not required to check. We are not required to check. We are not required to check remaining. We are not required to check remaining. We are not required to check remaining like. We are not required to check remaining like return types, access modifiers, like return types, access modifiers, etc. Like return types, access modifiers, etc. etc. Okay, next para. But in overriding, everything we have to check. But in overriding, everything we have to check. But in overriding, everything we have to check. Everything we have to check. Like everything we have to check. Like method names, argument types. Like method names, argument types, return types. Method names, argument types, return types, access modifiers, throws a keyword, throws a class, etc. Throws class, etc. That's all. Are you able to identify the difference between overloading and overriding? Are you able to understand, right? Overloading is the simple process or simple concept. Overriding is complex because several things we have to take care. Sir, from this discussion, what is the possibility to ask the question in the exam? Let me talk a simple example here. Say, sir, I have one method is there in the parent class. Public void. Sir, I have one method is there. Public void m1 of int x. Public void m1 of int x throws IO exception. I have one method in the parent class. Okay, like this method is there in the parent class. In the child class, which methods we can take? Sir, in the corresponding child class, parent class contain this method. In the child class, which methods we can take and by which concept these methods are valid? Okay, in the child class, just I am taking public void m1 of int I. Just let me write all options. Second one, public static int m1, public static int m1 of long L. Third one, public static void m1 of int I. Public static void m1 of int I. Fourth one, public void m1 of int I throws. Public void m1 of int I throws exception. Public void m1 of int I throws exception. Like, okay, void m1 of int I throws exception. Next, public. Okay, here I am taking static, public static. Okay, next void m1, public static void m1. 1 minute. Public static abstract void m1 of double d. That's all. Sir, my target is this method present in parent class. Which of the following methods we can take in child class? If I can take any method in the child class, by which concept it is valid is an argument you should aware. Sir, first method, can I take in the child class or not? Array, public void m1 is there in the parent. Can I take in the child class or not? Yes. If I can take in the child class this method, it will become overriding. Sir, by overriding rule, you can take first method. No problem at all. By overriding rule, we can take first method. Sir, can I take second method or not? Yes or no? Yes sir. Can I take second method? Yes sir. No. No, because sir, non-static to static not allowed. Next void replacer with m1, replacer with int not allowed. Like 100% pakka valid overloading concept. Are you getting overloading? Because method names are same but arguments are different. If arguments are different, then we are not required to check return type, access modifier, these things. That's why by overloading, happily we can take this concept. Don't get confusion. Okay, like third one, can I take this method or not? Sir, method names are same, arguments are same. What is this concept? Overriding. A non-static method, we are trying to override with static. Non-static to static overriding, possible or not? No, we can't. Based on overriding rule, it fails. Okay, fourth one, public void m1 of int I throws exception. Is it valid or invalid? Public void m1 of int I throws exception. Sir, this one is which concept? Overriding. Method names are same, argument types are same, overriding. But overriding, if a child class method throws some checked exception, compulsory parent class method should throw the same checked exception or it's a parent. But here it is the parent, it is the child, not allowed. So parent class method should throw either same or it's a parent. It's a parent. That's why. So this one invalid. Based on which concept? Overriding concept. Okay, last one. What about last? Valid or not? Invalid. Valid. Based on which concept it is valid? Overloading. Are you getting? Compile time error we are going to get. Okay, make sure. Sir, static and abstract combination is illegal. We can't declare static method as abstract, or we can't declare abstract method as a static. Illegal combination of modifiers. Illegal combination of modifiers is nothing but like. Are you able to get? So maybe a chance to ask this type of question in the exam. Simple. Consider this method in the parent. In the child class, which of the following methods we can take? Clear for all of you, right? Okay, at this point. At this. Better to take bit style. Consider the following method. Consider the following method in parent class. Consider the following method in parent class. Consider the following method in parent class. In parent class. The following method in parent class. Okay, take that method. Public void m1. Public void m1 of int x throws IO exception. Public void m1 of int x throws IO exception. Better to take within the box. Public void m1 of int x throws IO exception. Throws IO exception. Have we took right? Okay. Next, in the child class, which of the following methods? In the child class, which of the following methods? In the child class, which of the following methods? Which of the following methods we can take? In the child class, which of the following methods we can take? We can take. Okay, like take these examples. Okay, take all. Public void m1 of int I. Next, public static int m1 of long L. Next, public static void m1 of int I. Public void m1 of int I throws exception. Public static abstract, like take clearly and based on which concept it is valid. we have to decide. Completed, right? So take all. Why the last one is invalid? Because most of the people by overloading, it seems it is a valid like, but it's not. Static and abstract, we can't apply simultaneously for methods. By mistake, if you are trying to apply comparative method, we will get. Can I complete it, right? That's all. Public void m1 of int x throws IO exception. Right. Clear, right? That's all. There ends what is overriding, overloading, right? But now let me summarize these things under polymorphism, because overloading, overriding are by default considered polymorphism concept only. Correct or not? Okay, this is polymorphism. Let me summarize these points, right? Sir, what is polymorphism? How these things are going to fit under polymorphism? Keep subheading. Polymorphism. Subheading. Polymorphism. Polymorphism. Do you know what is polymorphism? Yeah, I hope it's a Greek word, it seems. Poly means many, morphs means forms. Many forms. Sir, one name but a multiple forms. Are you getting? One name, one but multiple. Only one but multiple forms. Is the concept of polymorphism, right? Best example for polymorphism, easy, layman example. So, yourself is the best example for polymorphism. Assume this person is you are. Within the house, what about your behavior? In front of your parents, what is your behavior? Very innocent. Okay, this is very innocent. Like your parents may feel, how this person can get on his life with this innocent nature. Like the parent may get the feeling. You are always talking about books, college, temple. This type of words are repeatedly used words in the house. But this person came out. He mingled with the friends. With his friends, the terminology is going to be changed. Do you know? Yesterday brand is not good. Today we have to change the brand. Next time after that, yesterday release cinema, first day, first show only we have to see. It's nothing but like the same person, if he's coming, he is mingled with his friends outside of the house. Behavior, different behavior you can expect. But the same person coming to Hyderabad from outside of your village is nothing but coming out from your village. Then different color by default you are going to show. Okay, this is. Do you know, sometimes we may get feeling whether this person is the same person is there in the village, is the person is the different or not, because complete color is going to be changed. Complete color is nothing but this person always talks about park, cinemas. Okay, is nothing but like complete color is nothing but innocent nature, complete gone. Isn't like person is the same, but based on the place, the behavior is going to be changed. Correct or not? Same person, but multiple behaviors. Person is the same, but multiple. This concept is nothing but what? Polymorphism, right? Best example for you. Sir, here I have one method is there. ABS method is there. Method name is the same. You can apply for int argument. You can apply for long argument. You can apply for float argument. Sir, same method, but different argument types. Method same but multiple. Same but multiple. What is this concept? Polymorphism or not? This concept is nothing but what? Overloading. Overloading is under polymorphism only. Same name but multiple forms. Polymorphism, right? Next, do you know method here in the parent class? Here see, in the parent class, marry method implementation for Subbalakshmi. Marry method implementation for Subbalakshmi, like. But same method in the child class C extends P. But same method in the child class, marry method implementation with whatever the name you want, Samtrisha or Naintara or Charmi, like any name you can take. Sir, have you observed? Method and name, method signature is the same, but implementations are different. This implementation meant for Subbalakshmi, but this implementation meant for Trisha or Naintara, like. Are you getting? So what is this concept, Anna? Okay, what is this concept? Overriding. Are you getting? Can I use the term? Is it polymorphism or not? Yes. Okay, sir, in the parent class, one type of implementation, but for the same method signature in the child class, another type of implementation is nothing but polymorphism. Okay, so same signature, method signature is the same, but in parent class one type of implementation, but in child class another type of implementation. Overloading is an example of polymorphism. Overriding is an example of polymorphism. Any explanation is required, Anna? Polymorphism, one name but multiple forms, is the concept of polymorphism, right? Are you able to understand, right? Okay, at this point keep supporting polymorphism. Polymorphism, one name but multiple forms. One name but multiple forms. Is the concept of polymorphism. One name but multiple forms. Is the concept of polymorphism. Is the concept of polymorphism. One name but multiple forms is the concept of polymorphism. Polymorphism. Okay. Example 1. Method name is the same. But we can apply. Method name is the same, but we can apply. For a different type of arguments. Method name is the same, but we can apply. For different types of arguments. Method name is the same, but we can apply different types of arguments. Within bracket. What is this concept, Anna? Overloading. Okay. Yeah, take this example. ABS of int, ABS of long, ABS of float. ABS of int, ABS of long, ABS of float. ABS of float. Overloading. Are you getting? Overloading is an example of polymorphism only. Okay. Next, example 2. Example 2. Method signature is the same. Method signature is the same. But in parent class, one type of implementation. Method signature is same, but in parent class one type of implementation. And in the child class, another type of implementation. In the parent class one type of implementation, and in the child class another type of implementation. And in the child class another type of implementation. Within bracket. What is this concept, Anna? Overriding. Okay. Take this example. Class P Marry method, class P, marry method, SOP of Subbalakshmi, any name you can keep, Subbalakshmi or Appalamma or something like your parents may arrange it. Next, class C extends P, marry method. So now your fancy names you can take, no problem at all. Charmi or Naintara or Trisha like. Have you completed right? Okay. So is the concept of what? Overriding. Okay. Overloading and overriding is the concept of polymorphism only. Sir, one more very commonly used concept this is. Sir, here just observe. We have list is there. In the collections and list and trapeze is there. Can you tell some implementation class of list and trapeze? Array list, linked list, vector and stack. You know, in the collections we will explain anyway. Array list, linked list, vector, stack. These are implementation classes of list and trapeze. List is the child and trapeze of what? Collection, right? Okay, anyway, just I will use. Sir, here we can use same list reference. Listen a bit carefully. We can use same list reference to hold either array list object. Sir, list L is equal to new array list. Valid or not? Yes, list L is equal to new linked list. Valid or not? Yes. List L is equal to new stack. Valid or not? Yes. New vector. Valid or not? Yes. We can use same list reference to hold array list object, linked list object, vector object or stack object. Sir, reference is the same, but runtime object can be anything, no problem at all. Are you getting? Can I use this concept with the polymorphism or not? Yes. Usage of parent reference to hold any. Sir, reference is one, but a runtime object can be any type, any child type. Usage of parent reference to hold a child object is the concept of polymorphism only. Are you getting that? Add example 3. Usage of parent reference, usage of parent reference to hold a child object. Usage of parent reference to hold a child object. Parent reference to hold a child object. To hold a child object is the concept of usage of parent reference to hold a child object is the concept of polymorphism. Is the concept of polymorphism. Concept of polymorphism or is also considered as polymorphism. Okay, like sir, take this diagram and this one also. Take both. List L is equal to new array list. List L is equal to new linked list. New stack, new vector. List L is equal to new array list, new linked list. New stack, new vector. New vector. New stack and new vector like. I hope completed right. Okay, so better to take that diagram also because array list, linked list, vector, stack under list only. Under list interface only. Okay, it's also polymorphism. Wherever parent reference can be used to hold child object is the concept of polymorphism only. Are you able to get right? But yeah, one very important difference I want to cover for you people. Okay, so even for the interview room also, this one is a very important concept. Okay, make sure. Sir, here what is the advantage of parent reference to hold child object? Polymorphism advantage I can tell. But here parent P is equal to new child. Is it valid or not? Parent P is equal to, sir, parent reference can be used to hold child object. Do you know? I covered one very important point. Parent reference can be used to hold child object, but by using that reference we can call only the methods available in parent class. By mistake child specific method, if you are trying to call, immediately compare a method you are going to get. Are you getting? Parent p is equal new child. Sir, assume parent class contain m1 method, child class contain m2 method. Sir, parent class contain m1, child class contain m2 method, right? Now I am calling p dot m1 method. Valid or not? Parent reference can be used to hold child object, no problem at all, valid. Sir, p dot m2 method, is it valid or invalid? Invalid. Immediately compare a method you are going to get. Are you getting? Saying cannot find a symbol, cannot find symbol. Which symbol? Cannot find symbol. Which symbol? Method m2. Method m2 in which location? Class p. Sir, very important. Parent reference can be used to all child object, but by using that reference we can call only the methods available in the parent. Child specific methods we can't call. Suppose if the parent class method override in the child, at runtime child method only will execute. But child specific method, the methods which are there only in the child but not in the parent, such type of methods we can't call by using that reference. Then immediately we ask, sir, then what is the use of giving the parent reference? Suppose, do you know, if I use a child reference, now observe, child c is equal to new child. Child c is equal to new child. C dot m1, C dot m2, both are valid or not? Alright, C dot m1 is the valid, C dot m2 is also valid. Then what is the use of giving the parent a reference? Are you getting? So we have some restriction. What is the use of giving the parent reference? Is nothing but, yes, polymorphism benefit is there if I use parent reference. Sir, parent reference can be used to hold child object. But the problem here is, by using this reference we can call only methods available in parent class and we can't call child specific method. Then what is the advantage of using parent reference? Like you may get, in which case we should go for this one, in which case we should go for this one. Okay, here I will explain. Are you able to understand? First at this point, and then what is the advantage I will discuss. Parent class reference can be used, parent class reference can be used to hold a child object. Parent class reference can be used to hold a child object, to hold a child object, to hold child object. But by using that reference, we can call, but by using that reference we can call only the methods available in, we can call only the methods available in, we can call only the methods available in, we can call only the methods available in parent class. We can call only the methods available in parent class, only methods available in parent class, and we can't call child specific methods, and we can't call child specific methods, and we can't call child specific methods, methods next para. But by using child reference, 1 minute, that's all. So take this example first. Take this one up to this. So better to take this diagram also. Up to this part, take. Very important discussion. Make sure you should have clarity or clear idea. Completed, right? Parent P is equal to new child p dot m1 p dot m2 p dot m1 p dot m2. Okay, so like I hope is clear for all of you, right? Okay, now but next para, but by using child object reference, but by using child reference, we can call both the parent and child class methods. We can call both parent and child class methods, but by using child reference we can call both the parent and child class methods. We can call both parent and child class methods, parent and child class methods. Okay, child c is equal to new child c dot m1 c dot m2. Child c is equal to new child c dot m1 c dot m2. Sir, can you tell valid or not? Both methods are valid. Okay, now you may ask, sir, what is the advantage if I use parent reference to hold child object? When we should go for this approach? Keep supporting. When we should go for parent reference, to hold a child object. When we should go for parent reference to hold a child object. When we should go for parent reference to hold a child object. To hold child object. When we should go for parent reference to hold a child object. Very simple. Legend this one. Sometimes what will happen is, we don't know what is the exact runtime object. I don't know what is the exact runtime object. If we don't know exact runtime type of object, happily we can go for parent reference. Simple. You may ask, sir, when can you give an example? Like simple example, I have one array list is there. Now legend a bit carefully. I have one array list is there. Sir, array list can hold which type of objects? Array list can hold any type. It may be student object or customer object, or it may be any object. Array list can hold which type of objects? Have you remember? Heterogeneous objects. Somewhere we covered in the collections, or we will discuss anyway. You should have basic idea. The array list, any type of object may be a chance to hold. Sir, now I want first object. Which method we have to call? I want first object. Which method we have to call? L dot get of 0. Sir, L dot get of 0, first object, 0th index object. 0th index object is what object? It may be student object, or it may be customer object, or it may be string object, string buffer object, any type of object. Then how you can hold? Sir, it may be any object. So we don't know exact runtime type of object. At runtime it may be student object, customer object, string object, or integer object. Then how I can hold this object? Simple, by using parent reference. Are you getting right? That's why the return type of get method present in array list class is object. Are you getting? So, sir, parent reference can be used to hold any child object, no problem at all. In this type of situations, parent reference is helpful to hold any type of runtime child class object. Is it clear? Right? Second example, here just observe. Is it advantage feature or not? Parent reference can be used to hold child object. When we should use this approach? If we don't know runtime type of object, then we should go for this approach, right? Another example, here see this example well. Sir, I have one m1 method is there. I have one m1 method is there. So this m1 method, I have one m1 public, here m1 method is there. Sir, based on some functionality, I may return array list object, or linked list object, or vector object, or stack object. Based on the functionality, I may return array list or linked list or vector or stack. Then what return type I have to keep? Can I keep return type as array list? If I take return type as array list, we should return only array list object, but not linked list or vector and stack. Sir, you may return any type of object, either array list or linked list or vector or stack. That's why which return type covers all these possibilities is nothing but better to use what? List reference. Are you getting? Now, happily, in the place of list, you may return array list or linked list, vector, stack possibility is there. Suppose tomorrow you are calling this method. Sir, I am calling M1 method. M1 method returns what? It may be array list or linked list or vector or stack. That's why what I will do, I will use a parent reference. Are you getting? So, if we don't know exactly runtime type of object, then we can go for what? Parent reference to hold that object. If we know exact runtime object, boss, it's always going to return array list object only, then use array list reference only. Are you getting? If we don't know exact runtime type of object, then we can go for what? Parent reference. Are you able to understand the difference, right? When we should go for parent reference, when we should go for child reference is nothing. I know runtime type of object, better to hold by using that particular reference only. I don't know runtime object can be any type, then better to hold by using common parent type. Are you getting? Okay, at this point. Yeah. If we don't know exact runtime type of object, if we don't know exact runtime type of object, if we don't know exact runtime type of object, exact runtime type of object, exact runtime type of object, then we should go for parent reference. Then we should go for parent reference. Okay. Next, the next example. For example, the first element present in the array list. The first element present in the array list. For example, the first element present in the array list can be first element present in the array list can be any type. First element present in the array list can be any type. It may be student type, it may be student object, it may be student object or customer object, it may be student object or customer object or string object or string buffer object. String object or string buffer object. Hence, the return type of get method is object. The return type of get method is object, which can hold any object. 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 Are you getting? So example, object O is equal to L dot. Object O is equal to L dot get off 0. Object O is equal to L dot get off 0. That's all. Are you able to understand? Okay, this is so. When we should go for parent reference, when we should go for child reference. So usage of parent reference to hold child object, is it advantage feature or not? Yes. So this type of facility is not there. Then how you can hold L dot get off 0? We can't hold because we don't know the runtime type. If a parent reference is not allowed to hold, then this type of facility we may miss. Usage of parent reference to hold child object is always advantage feature only. Make sure you should aware. Now, sir, let me summarize the differences, right? Let me summarize the differences. Here, see this one. Here I am taking, just a legend, very important. Here I am taking parent or otherwise, here see, child C is equal to new child. Sir, child C is equal to new child. parent P is equal to new child. This type of bit may be a chance to ask an interview room. What is the difference between child C is equal to new child, parent P is equal to new child? Are you getting? More specifically, they may ask. Example. More specifically, they may ask. Array list L is equal to new array list. Array list L is equal to new array list. Next example, list L is equal to new array list. Sir, what is the difference between these? Is nothing but like maybe a chance to ask. Sir, here when we should go for, sir, when we should go for this approach, when we should go for this approach, array list L is equal to new array list, or otherwise C is equal to new chain. When we should go for this approach, if we know exact runtime type of object, pass, my runtime object is always array list only, my runtime object is always student only, customer only. If we know exact runtime type of object, then we should go for what? This approach. Okay, this is. So we can use this approach if we know exact runtime type of object. Okay, I will dictate the point anyway. Sir, when we should go for this approach? If we don't know exact runtime type of object, exact runtime type of object, we don't know, then we should go for this approach. Are you getting? Next, second one. What is the advantage in this approach? What is the advantage in this approach? Advantage is, by using child object reference, we can call both the parent and child class methods. Both parent and child class methods. Here advantage. Here, by using parent reference, we can call only parent class method. Child specific methods we can't call. Child specific methods we can't call. Third one here saying the problem with this approach, we can use a child reference to hold that particular child object only. Sir, here I am using array list. This reference can be used to hold only array list object. Can I use this reference to hold linked list object and so on? No. So here we can use a child reference to hold one particular child object only particular child object. But we can use a parent reference to hold any child object. Any child object we can use to hold any child object. Any child object, like you have to tell the references, right? Are you able to understand? Sir, parent P is equal to new child C is equal to new child, or array list L is equal to new array list L is equal to new array list. What is the difference between these? Maybe a chance to ask. Polymorphism concept, advantage is there, problem is also there. What is the advantage? We can use parent reference to hold any child object, but the problem here is, by using that reference we can call only the methods available in parent class. Okay, take this one. Take the table first. I will dictate the points anyway. Child C is equal to new child. Parent P is equal to new child. Take the table and even example also. Very important for the interview room. Make sure you people should have clear clarity. Array list L is equal to new array list L is equal to new array list. Can I complete it right? These two. Okay, now at the first point. We can use this approach. If we know exact runtime type of object. We can use this approach if we know exact runtime type of object. If we know exact runtime type of object. Next, other side. We can use this approach. If we don't know if we don't know, exact runtime type of object, we can use this approach. If we don't know exact runtime type of object, object. Okay, next, by using child reference, we can call both the parent class and child class methods. By using child reference, we can call both parent class and child class methods. Parent class and child class methods. Parent class and child class methods. Next, within bracket, this is the advantage of this approach. Advantage of this approach. Next, other side. By using child object, by using parent reference, we can call only methods available in the parent class. By using parent reference, we can call only methods available in parent class. We can call methods available in parent class. And we can't call child specific methods. We can't call child specific methods. Okay, that's all. Next, within bracket, this is the disadvantage of this approach. We can call only methods available in parent class. We can't call child specific methods because we don't know runtime child object. What is the type of runtime child object? That's why. This is the disadvantage of this approach. Next, last one. We can use a child reference. To hold. We can use a child reference to hold. We can use child reference to hold only particular. We can use a child reference to hold only particular child class object. Only particular child class object. Within bracket, this is the disadvantage of this approach. Disadvantage of this approach. Next, other side. We can use a parent reference. To hold. We can use parent reference to hold any child class object. We can use parent reference to hold any child class object. This is the advantage of this approach. Completed, right? So it's a very important question for the interview room. What is the difference between parent P is equal to new child, child C is equal to new child, or array list L is equal to new array list, list L is equal to new array list? Observe advantage, disadvantage of both approaches, and when we should go for particular approach. Okay. Next, let me summarize the three WOOP concepts whatever we have. Here say this point well. Sir, here do you know? Here just observe. If you consider WOOPs, there are three concepts acts as pillars of WOOPs. Three major concepts, main important concept related to WOOPs. The first concept, here second concept. Like here see, first concept we covered in the last session somewhere, encapsulation. Have you remembered? We covered already encapsulation. Do you know encapsulation? Okay, first concept. Second concept we covered polymorphism. Of course, now we discussed polymorphism. Third concept we covered inheritance. Have you remembered inheritance? Do you know about one word? What is that word, Anna? Security. Encapsulation always talks about one word. What is that word? Security. Okay. Next, polymorphism always talks about one word. What is that word? Flexibility. Flexibility to the programmer. Getting flexibility to the programmer. So is nothing but polymorphism. Inheritance always talks about one concept. What is that concept, Anna? Reusability. Reusability, right? These three concepts are called encapsulation, polymorphism, inheritance. These three concepts are by default considered pillars. Three pillars of OOPS. These three concepts are by default considered as three pillars. Basic important concepts of OOPS concept is nothing but like take this part. So just encapsulation, polymorphism, inheritance. Encapsulation, polymorphism, inheritance, like make sure take clearly this diagram anyway. So even you can add the comment also. Three pillars of OOPS. Yes, completed, right? Three pillars of OOPS: encapsulation, polymorphism, and inheritance. Okay. So just observe. There is one very popular definition for polymorphism, circulated like anything in the internet. Okay, this is just I'm sharing with you. But whether it is a correct or not, I don't know. So even I am not having any experience in that area. So can you tell what is the polymorphism? One name but multiple forms is the concept of polymorphism. Overloading, overriding, these things under. One very funny definition which is populated like anything over the internet, I will show. But before that, just let me give one small summary table also for this polymorphism. One small summary table, and then I will go for that funny definition, right? Sir, yeah, polymorphism. We covered already polymorphism. There are two types of polymorphisms we have. What is the first one? Static polymorphism. Sir, static polymorphism or compile time polymorphism. Do you know compile time polymorphism? Compile time polymorphism. Or is there any other word for compile time polymorphism? Or early binding. So do you know for this there are two examples are there. One is overloading. Overloading is the example of static polymorphism only. Second one, method hiding. Have you remembered? Method hiding and polymorphism. So both are examples of compile time, right? What is the other word? Can I spell out? What is the other word? Dynamic polymorphism. Or runtime polymorphism. Dynamic polymorphism or runtime polymorphism. Or what is the last one? Late binding. Sir, can you tell for this? What is the example for this? Overriding. Okay, take this summary also. Polymorphism, static polymorphism, compile time polymorphism or early binding. Overloading and method hiding are examples. Take clearly. Static polymorphism, compile time polymorphism or early binding. Overloading, method hiding are examples anyway. Completed, right? Next, dynamic polymorphism or runtime polymorphism or late binding. Example for that is overriding. Okay, completed, I hope. Next, up to this clear, right? Now keep submitting. So keep submitting first, whether you are taking or not. Beautiful definition of polymorphism. Beautiful definition of polymorphism. Beautiful definition of polymorphism. But don't ask, sir, whether it is the correct or not. I am not having any experience in that. Okay, you can cross check. Here, see this one. Here I am taking. Here, observe this word. Okay, sir, here just have a look once. A boy starts love with the word friendship. So usually most of the times, gents are going to start at bus stop or classroom or otherwise. Why don't you? We are just friends like. Then the cinema is started. A boy starts love with the word friendship, but girl ends love with the same word friendship. So one fine day she is going to come and she will give wedding card saying we are friends forever. Is nothing but like. Okay, whether it's a correct or not, I don't know. So what is the same? So but the attitude is different. Are you getting right? So one person is used this friendship word to start, but another person is used the same word to ends. Is nothing but like ends love. This beautiful concept of oops is nothing but polymorphism. Okay, here if you want you can replace boy with girl or girl with boy, I don't know. Okay, this is whether it's a correct or not also, I don't know, but this is very popular, very popular definition which is circulated like anything in the internet. Okay, this is very popular about polymorphism oops concept, right? Better to take whether you are accepting or not, or if you are interested you can take, otherwise you can ignore. Word is the same but attitude is the different. So don't ask whether it is a correct or not, I don't know. Even I am not having any experience in that. Completed, right? So okay, that's all. So there ends the concept of polymorphism what we have. So now in the next step we have to discuss about coupling, cohesion, typecasting, next instance control flow, static control flow, followed by constructors concept. Okay, right.